This week we are going to be looking at some of the fascinating places that animals build for themselves. Zoos were built for them by us. We're going to look at some animal homes in nature, which, let me just say, they are built with beaks and claws and paws and tails, and yet animals manage to create some of the most fascinating structures on Earth. And so we're going to be taking a look at that today, because when we talk about things like when we talk about habitat destruction, we're not just talking about things like wetlands and forests in the abstract. We're talking about homes and families and the things that we're going to take a look at some of those homes and how they relate to the animals themselves, how they relate to their habitats, and everything else. So first, let's just talk about the nesting instinct. It's a common term. We all hear about the nesting instinct. The nesting instinct essentially arises from three things in animals. It's their need to raise their young, they need to protect themselves from predators and from extreme temperatures. And in nature, it sort of turns out that the complexity of a nest tends to be related to the level of parental care that the parents provide. That's not always the case. Some of them are just darn impressive places to live. And one common creature that's not exactly known for its parenting skills builds its home with such precision that it has actually, it took mathematicians 2,000 years to figure out the secret of this one particular type of animal home that we're going to look on a little bit later. So more than any other animal home, its bird nests are where architecture really becomes art. There's maybe 10,000 or more species of birds in the world. They each have their own kind of nests, and so birds exhibit sort of the greatest variation in their nest compared to other kinds of animals. Sometimes they're very simple, scrapes in the ground. Sometimes they're really basic, like a bluebird or robin nest. Sometimes they're in impossibly difficult places, like on the sides of cliffs or on the top of peaks. They can be woven. Birds exhibit a great deal of ingenuity and variation in the kind of nests that they build for themselves. So this bird, for example, this is the red oven bird. It's a native of South America where it rains a lot, and so animal homes often they tend to reflect not just the animals themselves, but because they're built from materials that are around, that whatever kind of habitat the animal's living in, they're going to build nests that are built out of that kind of material. So it rains a lot in South America, so naturally there's a lot of mud, and so the red oven bird builds its home out of mud, out of adobe, basically, which is a mixture of mud and grasses, and it takes a couple weeks and carefully constructs a sort of an encased and very weather-hardened dome with an inner chamber inside that actually protects the eggs even further from predators and from others. So the red oven bird builds its nest out of adobe and builds them into tall apartment complexes. In a sense, it just can stack them up over time. So this is just one of the many different kinds of things that birds like to build for themselves. Totally just unique kind of structure. Well, some animals build more than just mere nests for themselves. Some birds, and we're going to look at the largest bird nests in the world. Some animals build basically cities with gardens and climate control that may house hundreds or thousands, or in some cases even millions of animals. And in the among birds, we're talking about the sociable weaver nest, which is a native of southern Africa in the Kalahari Desert. This entire thing is a bird's nest. These things look like haystacks dropped into trees. They may be hundreds, if not, of bird couples and their young may live in there. They're built to last for generations. The oldest known sociable weaver nest, something like this, has been known to be about 100 years old. They are meant to be just permanent. They are extremely cleverly constructed. You can see here kind of a close-up. There's hundreds of little holes where they come in and out. They are so large that towards the inside It's warmer, which is good for the cold winter months there in the Kalahari Desert. And then towards the outside, the chambers are a little cooler, so providing sort of a cooler shade during the summertime. So, as I said, these nests may hold more than 100, couple hundred birds and their young. Sometimes they're so inviting that other animals move in, like owls and lizards and other things. And as long as they don't eat the residents, they're basically allowed to live. And they are just a lot of the holes have sort of spikes, sort of spiky straw around them as a way of keeping out predators. And so this is just another version of just the many ways that birds can live together is in these large colonies. And later on in the show, we're going to be looking at some other very large colony structures where animals live. But when it comes to birds, perhaps one of the most creative bird nests of all is from the bowerbird of eastern Australia. Bowerbirds, these are built by the male of the species, and they are built entirely. The birds don't actually live in these. These are built entirely for the purpose of attracting a mate, and essentially, as it comes down to it, the best bachelor pad wins. The male bowerbird just may spend a long time just not only building this little tent out of twigs, but also collecting. They love to just collect colorful things, and they decorate the whole place with them. And you can see they pile them up by colors. They especially like the color blue, and they'll find berries and beads and glass and bits of discarded plastic that humans leave around, and they create these just magnificent structures as a way of attracting a female. And the bowerbirds have been seen to like check out their work from various angles to make sure it looks good from over here and looks good from over there. They put considerable effort into them. They use them for mating, and then they leave. It's absolutely, and they do this with their beaks. Keep in mind, they do all this with no hands, no thumbs, nothing. So, and these are found in Australia, and you know how much I just love animals of Australia, and they're a fascinating variety that we don't see anywhere else. So this is the bowerbirds, and they're just amazing constructions. But as everyone knows, the real architects of the animal world are the beaver. Beavers are not just home builders, they are landscape architects. And let me just point out that when we think of nests and animal homes, we mostly think of birds, but in fact, many types of species of animals build nests. Mammals do, insects, spiders. Apes build nests in trees, and actually it is sort of theorized that the ability to get a good night's sleep is part of what may have spurred the evolution of humans from apes, because apes could build and chimpanzees could build their nests high in branches and just away from predators and just get a good night's sleep. But beavers are the real architects, because beavers and humans are the only animals that actually change their landscape to meet their living requirement. And we think of, when we think of beaver dams, we think about, beavers as sort of busily paddling to and fro, dragging, sticks and branches and things onto their piles. The fact is that with a beaver dam, they're actually changing the landscape. And I don't know if you can see, but in back, the water level is higher. That is the reason for building these dams. By when you build a dam, you raise the water level and cause the river or stream to overflow its banks, and then you basically create a pond. And from those ponds, beavers don't live in the dams, by the way. They build their lodges on the side of the edges of these ponds that they create. And they is made of branches and twigs and mud. And these things are very solid and really compact, safe haven from predators. And one of the ways that they protect themselves from predators is the entrance to this is actually underwater. They build the dam to raise the water level, to create a pool so they can create an entrance. By raising the water level, they are able to go farther in search of wood for their construction materials. You can see the line of trees in the background here. Well, by raising the water level to a pond, they can swim towards the trees to be able to cut them down and bring them over. And of course, if you've ever tried to drag a piece of lumber, it is much easier to float a tree or log on top of water than it is to drag it over land. So they basically change the entire environment to their whole surrounding area in order to suit their needs to build these. And in doing that, they create wetlands. They create more habitat for fish and for and ducks and other waterfowl. Now, beaver dams can actually be quite large. They can be as long as 500 feet. The largest beaver dam in the world that's known is sort of smack in the middle of northern Canada. It is so large it can be seen from space, and in fact it was discovered as a beaver dam by Google Earth satellites in 2007. It's actually been seen as far back, if you go back in NASA satellite imagery, it's been seen as far back as 1990, but apparently no one knew then what it was. This beaver dam, if you can kind of see the edges of it there and the pool that it's created, is 850 meters long. That is more than half a mile, and it is estimated to have taken some 20 years to build. Probably was created by the joining of several dams into a single dam, and has housed thousands of beavers spanning many generations. Let me just, yeah, it is seen from space, and apparently it's a tourist attraction now. I haven't confirmed that, but I did read that in one place. But it's, as you can see, it's out in the middle of northern California in northeastern Alberta, and a fairly inaccessible place. But the largest beaver dam in the world can actually be seen from space. Now, there's another animal, another mammal that's actually a fantastic builder. Prairie dogs. But unlike beavers, prairie dogs dig. They don't build, they dig. They live in very complex tunnel systems that they are so large and complex that they are actually called towns. A prairie dog town. They can cover half a square mile underground. So you are not going to go chasing after a prairie dog underground in its own home. The largest recorded prairie dog town was known to have covered about, sit down for this, 25,000 square miles, and may have housed as many as 400 million prairie dogs. Now, these are fascinating structures in the way that they're constructed. Because pay attention to the mound structure here. I'm going to come back to that in a second. These prairie dog towns are really very extensive underground things that they have. There are bedrooms, there are nurseries for the young, there are food caches, there are actually sort of motel rooms where couples can just go to mate. They have multiple entrances. So some of these entrances have lookout posts so they can warn of predators. And of course, there's multiple escape routes. But we're just seeing a simple cross-section. Keep in mind that this kind of structure can extend underground for many, many square miles. And the thing about the mounds, here's something, a little fascinating thing. You would think it might get pretty stuffy underground. Well, by building these mounds, in other words, by making some entrances higher than others, without getting into a whole lecture on aerodynamics, what that does is that creates a pressure gradient which actually causes air to flow through the tunnels. It's the same kind of principle, aeronautics principle, that makes an airplane wing able to lift up. But you can just building some of the entrances higher than others actually creates airflow within these tunnels using just sort of the principles of aeronautics. Now, I'm sure there are no prairie dogs out there with degrees in aeronautics. They've known this long before, and humans had to figure it out for ourselves. Well, another animal that it does. I mean, it makes sense. We look at it now mathematically. We know about these principles, but prairie dogs, they've just been doing it all along. And this kind of just sort of natural knowledge of how to do things. I mean, a lot of animals have to learn to build their nest. For example, birds don't just get born and then they just suddenly know how to build a nest. That's the case of bowerbirds and their elaborate structures. It's the case of many birds where they have to learn it over it's instinct, but they also have to learn it over the course of a few seasons. In many cases, they're not always known. And they, some animals, they just know how to build their nests and their hives, and we're going to look at that in a moment. But sometimes these are learned as well. Now, another animal that is known for basically creating these mega cities underground not a bird, it's not a mammal. We go into the world of insects. The cathedral termite of Australia builds these mounds out of basically mud and chewed wood and dung and saliva as glue. These mounds can be as tall as 15 feet or more. You can see a little selfie or a little picture with some tourists next to this one, that if these guys are 6 feet tall, that is easily a 12 or 15 to 18 foot tall mound here. These, as tall as they are, underground, these termite colonies can cover several acres, and they are basically self-contained cities, metropolises that may have millions of termites living in them, because you're only seeing, sort of, so to speak, the tip of the iceberg here. It can cover several acres underground. They have many of these colonies maintain fungus gardens that the termites actually fertilize with plant matter in order to create food for their populations. They are climate controlled with tunnels that sort of serve as ducts to regulate airflow. And these towers, condensation, or I should say condensation, collects inside these towers, providing water for the colonies. So what we're seeing is a little sort of 15-foot mound here. That's just the sort of entrance to a much, much larger self-contained termite metropolis that extends very far underground. So the real, as beavers are to the mammal world, as the sort of master builders of the land, there is another animal who's one of the most amazing actual home builders on earth, whose the mystery of these homes have actually eluded mathematicians for 2,000 years. And it took actually the invention of differential calculus by Isaac Newton to be actually really fully unlock the mysteries of these. And I'm talking about beehives. Beehives are just masters, are just the most unbelievable constructions ever. They have given math students something to think about for thousands of years. The final proof of just how efficient and how just perfect that beehive construction is came about in 1999. Required something like 19 pages of mathematical proof to prove that the beehives are actually the most perfect structure. And I've actually constructed a little some model beehive that I found a little template to do this. As it turns out, you may wonder why they've chosen hexagonal structures. Well, it turns out, and on my blog post that I wrote about all this, there are links to the mathematics, that it turns out that the hexagon is actually the most efficient shape that you can use to create cells that, in other words, have the sort of the smallest perimeter. So in other words, you can fit the most hexagons into a space using the least amount of materials that there are. Triangles will fit together, squares will fit together. Triangles, squares, and hexagons are the only three geometric shapes that will actually fit together like this and don't leave any gaps. But the hexagon is the one that uses the least amount of material to actually construct. And they are fitted together in a pattern like this. Now, the back of the cells is also a piece of engineering, and this is the part that actually took differential calculus to figure out that this was the most efficient shape. These are actually, the backs of honeycombs are not flat. They are actually sort of peaked things composed of shapes called rhomboids. And it turns out that, you can make these like bigger or smaller, but it turns out that the size and shape of these particular rhomboids, again, like the rest of the cell, provide the maximum volume with the least amount of materials. They're absolutely efficient. And these honeycombs, they're not flat on the back, but you wouldn't believe how long it took me to actually make these things. They are meant to then fit together in an offset way, so that let me see if I can use my little thing here, so that they fit together, and so you are actually able to fit more of these things. It gives us a great amount of structural stability. And the honeycombs, as they're in a thing, they tilt, actually are tilted up a little bit to prevent honey from running out. They grow perfectly vertical because the bees can actually use their heads as plumb lines to measure vertical lines. And so this is where we get the honeycomb. And so now basically you can build a better mousetrap, but you cannot build a better honeycomb. It turns out that this is absolutely the most efficient, mathematically precise shape, and that you can construct a honeycomb to do what the bees are doing. When we talk about habitats, we're talking about animal homes, and we're talking about families. And when because they all build their homes from the materials that they find around them, when those materials are no longer there, when an area no longer has trees, birds no longer have materials or places to build their nests, and so bird populations go away. So I just kind of wanted to personalize all this. Like when we talk about habitat destruction, it's not abstract things like wetlands and forests. It's birds and prairie dogs and beavers and bees and these sort of things. So that is it for today's show. I am Randy Lyman, the Pet Uncle. You can find me here on the Petscope TV and also on my own Facebook page, /Style Pets Boutique. I've got show notes and replays here at WagOfTheTale.live and on Medium. And you can reach me on Twitter, Periscope, on my blog at thepetuncle.com, and by email at randy@thepetuncle.com. So thank you for watching another show. Next week we will continue our look into Home Sweet Home, Where Animals Live.